from chemicals used in textile industry. This webinar will be beneficial to gain understanding on hazards and risks associated with chemicals used in textile industry and information on guidelines to implement chemical safety program at the workplace. I would like to introduce myself. I am Vivek Vani, presenter for this webinar. I have worked for more than 15 years in textile dyes and chemical industries, out of which major experience covered working with Dystar and Huntsman. Let me give you a disclaimer before we start this webinar. The contents, views and thoughts expressed in this webinar is accurate to the best of our knowledge. Though all care has been taken while researching and compiling the contents provided in this webinar, Nimca Tech Technical Services accepts no liability for correctness of information. The subject matter is dynamic and participants are advised to check for all the latest updates. All images in this webinar are for training and educational purposes only. Before we start the webinar, we would like to simplify the webinar technicalities with some instructions. We recommend that you use headphones for good audio quality. Please ensure that you are muted by clicking on the green mic icon on the control panel. If you face any audio related difficulties or wish to clarify any queries, please do not hesitate to communicate with the organizer using the chat box on the right side of the screen. All the queries should be mailed to adminnotes@nimcatech.com and the presenter will answer via email. So in today's webinar, what we will cover is what are the hazards and risks associated with the chemicals? How do I know that the chemicals I am using are hazardous? How do I manage the chemical risks at my facility? And what are the steps for chemical safety at the workplace? So what are these chemical risks? Here I have tried to explain you the hazards and risks to the workers as well as to the property and the environment. So all the compressed gas cylinders which are used in the plants are hazardous because they have high pressures inside them which may cause explosion on contact with flame or heat. Flammable gases and solvents which are used in spot cleaning will be easily ignited by heat or sparks or flames and will form explosive mixtures with air. The chemicals used in textile industry can pose risk to workers' health and safety. There could be many areas where workers may be exposed to the hazardous chemicals. For example, in this picture you can see that the mist of potassium permanganate can cause watering in lungs if proper protective equipments are not used, and this may result in pulmonary edema over a period of time. Dust from dyes as well as solvents which are used for screen making in printing can cause respiratory tract problems, nausea, headache, or even may be toxic if inhaled or absorbed through the screen. Bleaching agents used in textiles such as peroxides and hypochlorites can cause skin corrosion. It means it can give you skin burns if not used properly. Chemicals like urea formaldehyde resins and softeners which are used in textile finishing can create respiratory tract problems. Urea which is used in textile printing or other phosphate-based chemicals used in textiles can cause eutrophication of water bodies, which does not allow sunlight to pass through water, and it can be dangerous for aquatic life. Other risks from these chemicals can be CMR, that is carcinogenic, mutagenic and reprotoxic chemicals. These chemicals are chronically toxic and they can have serious impact on health. For example, if we take some dyes which are used in textiles are carcinogenic. Phthalates which are used in plastisol printing or plasting are reprotoxic. Secondly, endocrine disruptor chemicals can mimic the hormones due to similar chemical structures, which disturbs the endocrine system of human body. Such chemicals can cause birth defects, or they can even cause feminization and cancerous tumors. For example, if we take the nonylphenol, which is used in detergents and washing of agents, this is an example of endocrine disruptor chemical. Persistent bioaccumulative and toxic chemicals is another risk. Persistent chemicals do not easily biodegrade in nature. If we take an example of a plastic bottle, it remains in nature for around 400 years. And if we relate example of persistent chemical to textiles, then oil and water repellent finishing agents are persistent in nature. Bioaccumulative chemicals accumulate in the fat tissues of animals. These chemicals can enter humans through food chain. Heavy metals such as mercury are bioaccumulative in nature. Toxic chemicals are toxic to environment and aquatic as well as terrestrial life. Cyanide-based chemicals, which are used in electroplating of metals, are the examples of toxic chemicals. Very persistent and very bioaccumulative is another risk of chemicals. They are resistant to environment degradation and they have been known to persist in the environment. They also bioaccumulate in human and in animal tissue. So again, 4-nonylphenol is an example of very persistent, very bioaccumulative substance. So how do you think that these chemicals get into humans? So humans are exposed to the chemicals via 3 routes. One is inhalation, absorption through skin, and ingestion by mouth. In case of inhalation, the chemical vapors are inhaled through nose and that goes into lungs. Whereas direct contact of chemicals can cause absorption of the chemicals through the skin pores. In mouth, through ingestion of chemicals or contamination of chemicals in the vessels containing the food. So in textile factory, generally most hazardous chemicals get into human body through inhalation as well as absorption through skin. Chemicals entered in our body can cause damage to vital organs like lungs, liver and kidneys. So this is okay, but how do I know that the chemicals I am using are hazardous, or how to identify the hazards in chemicals? The chemical labels which are displayed on the chemical containers and provided by the chemical manufacturer is a good source that can tell you hazards in chemical. Second source to identify hazards is MSDS or SDS, which is provided by chemical supplier or manufacturer. Information on hazards is given on label of chemical container. As per GHS, a label for hazardous chemical must have 5 elements. These are product identifier, pictogram. There may be one or more pictograms depending on the severity of the hazard. Signal word, hazard statements, and precautionary statements. The product identifier is commercial name of the chemical that must be same as it appears on the label of the container. The signal word is used to indicate the severity of hazard. The signal words are of two types, danger and warning. Danger stands for high severity and warning stands for less severity. The pictograms denoting the hazard category must be displayed as per GHS guidelines. In case of more than one hazard category, more pictograms need to be displayed. H statements and P statements should also be displayed on the label of the chemical container with their descriptions. Second source of information of hazards is SDS or MSDS document. This document is given by the suppliers of industrial chemicals to inform users about the potential hazards in chemical. H statements for the hazardous components in the chemical formulation must be mentioned in section 2 of the MSDS under the title Hazard Identification. Other descriptions pertaining to these H statements are also detailed in section 16 under the title Other Information. Let me give you an example of section 2 of an SDS or MSDS. You can see here that the H statements provided in this SDS are H315 and H334. So H315 describes that the chemical can cause skin irritation. Pictogram pertaining to this H statement is the first one for skin irritation. H334 describes that it may cause allergy or asthma or breathing difficulties on inhalation. Pictogram pertaining to this is given here. We will use this data to develop chemical risk assessment sheet in the subsequent slides. So under H statements, H200 series denotes physical hazards, H300 series denotes health hazards, and H400 series denotes environmental hazards. These H statements are provided by GHS for all the hazard types. Here are some examples of H200 series, that is physical hazards. An example of this is H220, which is extremely flammable gas. It is denoted by H220. A list of such statements is available in physical hazard series. Similar to this, here is the statements for health hazards and environmental hazards. H302, which denotes harmful if swallowed, whereas H350, it may cause cancer. H400 series, which denotes environmental hazards. Here you can see that H402 is harmful to aquatic life. So on the basis of H statements provided in the SDS or MSDS, you can decide an action plan for the chemicals, which we will see in the subsequent slides. Another way to identify hazards in chemicals is GHS hazard pictograms. As per GHS, there are 9 pictograms which are used to depict and identify the hazard category of chemicals. For physical hazards, there are 5 pictograms assigned: explosives, flammable, oxidizer, gases under pressure, and corrosive. These are the 5 pictograms in physical hazards. For health hazards, there are 4 pictograms. These are CMR, that is carcinogenic, mutagenic, and reprotoxic, toxic, corrosive, and skin sensitizer. as the corrosive chemicals or substances have potential to corrode metals as well as they can cause severe skin burns and eye damage. They are covered under physical and health hazards. So you can see that this is a common pictogram in physical hazard and health hazard. For environmental hazards, the pictogram used is aquatic toxicity. So this is about the pictograms, but the next question that can come to us, that how to assess the chemicals for risks. So in order to assess the chemicals for risks, following actions should be taken. Prepare an inventory of chemicals being used. Second is to map these chemicals for hazards. Third is to map the amount of exposure. And fourth is to develop an action plan to control these hazards. So I will give you practical example through an Excel sheet in this next slide. So here this is the spreadsheet for inventory mapping and risk assessment for chemical. It should cover the following. It should have a name of the chemical. It should also denote the supplier name, use or application, place of use, whether the SDS or MSDS for that chemical is available in the facility. That should be specified here. H statements as given in section 2 or 16 of MSDS, and description of that H statement or description of hazard, which is also given in MSDS. So here you can see that a chemical ABC, SDS of this chemical is available with us, supplier name is given, and the application area is given, and where it is used, in which area, and H statements related to this are H226, H334 and H350. So this H200 series, that is physical hazards, the chemical is highly flammable. H334, that is it irritating to eyes, and H350, it may cause cancer. So this information we can obtain from MSDS to identify hazards in chemical. The next step after identification of hazards is to map the amount of exposure. For example, a worker may be exposed to more time than a visitor, a manager or a supervisor. So how to calculate this exposure? This is calculated on the basis of time weighted average and threshold limit value. Time weighted average is average exposure on 8-hour workday or 40 hours per week, and threshold limit value is the level of exposure without any adverse effects for the working lifetime of the worker. These limits and values are mentioned in SDS for chemicals which have impact on health of worker. So this way we can map the exposure of chemical. For an example, I can tell you that a worker who is spraying, using this spraying, he is exposed to spraying chemicals for more time than the worker who is not working in the same department. Thus, risk to these workers is great or high. Similarly, if the chemical used in the facility is toxic to aquatic life, then discharge of that chemical into river bodies can harm the aquatic lives. However, if the facility is recycling their wastewater, then the risk is almost zero or it is reduced drastically. So thus, what I mean to say here is the exposure and hazard are, these both are the deciding factors in chemical risk assessment. To relate this, I will just share with you with an example. So hazard, risk and exposure. Hazard is the intrinsic property of a substance and it has the potential to cause harm to humans, property or environment. Exposure is possibility of a substance to come in contact with the body and environment. And risk is the probability of a substance to cause harm or have adverse effect. If any of this hazard or exposure is absent, then there is no risk. So as shown in this example, a worker is at risk if exposed to sulfuric acid. In order to lower the risk, hand gloves can be used while handling this chemical. There will be no risk if automated dispensing systems are used for handling and transportation of this chemical. So now our next area with regards to this chemical risk is how do I manage this chemical risk? In order to manage the risk from chemicals being used, following action plans should be prepared. Number one is implement safe measures for chemical handling, implement safe measures for storage of chemicals, prepare a phase out list of chemicals with carcinogenic, mutagenic and reprotoxic substances as well as endocrine disruptor chemicals, and develop an emergency response plan. So this is how you can prepare on the basis of your hazards. You can prepare a control measure summary sheet which can involve a list of chemicals, where they are used, what kind of personal protective equipments to be used for handling these chemicals, whether this chemical is flammable or not, whether it needs to be phased out on the basis of hazards identified. If there are severe hazards are there, then it should be phased out. Otherwise, it can be used with appropriate personal protective equipment. And the reason for this phase out should also be mentioned. So these control measures can be illustrated in an Excel sheet, and it has got this following list. That is chemical name, place of use, PPE required, flammability, phase out, and reason for phase out. Information from SDS can be used to understand the PPE usage where chemicals are skin irritant or respiratory sensitizers, storage precautions for those chemicals which are flammable, and developing a phase out list of chemicals for health and environmental hazard chemicals. So from this table, now we will go to next slide where I can individually tell you about these chemicals. So chemical ABC, which was the first chemical in our earlier slide, this does not require any precautions for storage or during chemical handling because SDS of this chemical or MSDS of this chemical does not convey any hazards. Chemical LMN is harmful to aquatic organisms. Thus, facility should substitute with safer alternative. But this is not the exact case. In case if the facility is recycling their wastewater, then they can use this chemical because there is no environmental risk involved as facility is not discharging this chemical. Chemical XYZ, this is flammable and thus it requires separate storage precautions with fire safety. However, as per SDS information, this chemical is harmful to human health as it can cause lung damage. Thus, this chemical should be put in the phase out list and it should be substituted with safer alternative. This is the way you should carry out chemical risk assessment and implement control measures wherever required. In textile factories, accidents may occur while handling or storage of hazardous chemicals, which can result in injuries or even death of person or even damage to the property. Some of the examples of accidental emergency scenarios can be fire or explosion due to explosive, ignitable, flammable chemicals, spillage or leakage of chemicals, release of toxic gases, medical emergencies due to exposure of chemicals. So in order to control such emergencies, locations of fire extinguishers, fire alarms, spill control kits, first aid kits should be included in emergency response plan. A written procedure for actions should be documented. Telephone numbers of local fire department, ambulance services, hospitals should be available and displayed at the strategic locations in the facility. Clear pathways guiding towards exits should also be displayed. So these are some of the pictorial representations of the chemical safety measures in case of emergencies. So here you can see that these are the fire extinguishers, these are eye wash and body showers, first aid kits and spill control kit. Besides engineering control, which are implemented in your factory, injuries may still occur. Lungs can be affected from breathing in contaminated air. Injuries to head and feet from falling objects of material can also take place. Eyes can be damaged due to flying particles or chemical splashes. And adverse effect on skin from corrosive chemicals. So in order to protect from such injuries or accidents, we need to have equipment measures, and these equipment measures are personal protective equipments which should include safety shoes, goggles, aprons, face shield, gloves and nose masks. Let us now see how these preventive and protective measures can be implemented for chemical safety. Nose mask should be worn by the worker in the area where there is possibility of dust or dye-stuff particles coming into contact. So you can see here example of N95 nose mask or some air purifying respirators which can be used for chemicals such as formaldehyde resins, liquor ammonia and potassium permanganate. N95 nose mask or an air purifying respirator has got filtering facepiece and protection factor of 10s. A protection factor of 10x indicates that concentration inside the facepiece is reduced by 10 times compared to the outside concentration. Goggles and face shields are used to protect eyes and face. Protective eyewear can be made up of plastic or glass. Where there are denim processings or in case of denim laser engraving process, special dark eye protection glasses are required to protect from intensity of laser beams. So apart from gloves, we will have, apart from these goggles, we will have gloves that should be worn by workers while handling, mixing or spraying of chemicals. The types of chemical resistant gloves include butyl rubber gloves, nitrile and neoprene gloves. Here you can see that which are the suitable for what kind of chemicals and not suitable. So these butyl gloves are not suitable for halogenated solvents. Nitride gloves are not suitable for handling strong oxidizing agents, whereas neoprene gloves protect against gasoline and organic acids as well as alkalis. Aprons and lab coats should be used while transferring the chemicals from bulk containers into machines. This will also avoid spillage of chemicals directly onto body. Aprons can also protect from hot objects or articles which are used during stentering or curing process. Safety shoes prevent from injury due to contact of slippery surfaces and falling objects. Non-skid safety shoes should be worn while working with liquid chemicals and while transporting bulk chemical drums. So after this, we will cover some important aspects on developing a chemical safety program in the facility. And these are communication of hazards through a labeling system, communication of hazards through training and safety signboards, and establishing standard operating procedures. One of the elements of developing a chemical safety program is communication of hazards. This should be communicated to include internal chemical management procedures, SOPs on storage, use, disposal and transport of chemicals, information given in MSDS or SDS as well as labels on containers, proper usage of personal protective equipment, first aid and firefighting, management and disposal of waste chemicals. The second element in chemical safety program is training. Training and instructions should be given to ensure that employees handling chemicals have skills and competencies to perform their task in safe manner. So this training should include the topics such as pre-purchasing requirements, laws on chemical use, classification of chemicals for hazards, chemical risk assessment, labeling for hazards, use of personal protective equipment, emergency procedures. Safety signboards should also be installed at the chemical stores and other work areas. This will highlight the hazards and safety measures required at the work area. Some examples of such safety signboards are shown here. Establishing standard operating procedures or SOPs is one of the important elements in developing chemical safety program. So these are the written document that describes policies, procedures and standards and responsibility required for a particular area of chemical management. So as part of this chemical safety program, SOPs should be prepared for chemical storage and handling and transportation, chemical documentation, purchasing practices for chemicals, labeling system for hazard communication, and emergency plans. So this is about developing chemical safety program, and now we will come to the last part, which are the good practices followed in the factory as far as chemical safety are concerned. So I will give you some examples or illustrations. So here you can see that dyes and chemicals that should not be stored in haphazard manner. They should be stacked properly, and they should be provided with some containment or traps. So this is a good practice, this is not a good practice. So chemical store should also be not close to boiler, and there has to be a separate place for storing flammable chemicals. Chemical containers should not be left in sunlight or in open. They should have covered storage. I will also explain you some good practices in the next slide. So here you can see that the sand buckets are kept near flammable chemicals. So this is good practice, and the area is also cordoned. In the second picture you can see that there is a container where there is a bulk chemical stored and some containment is provided. So in case of spillage of this chemical, it is collected in this containment area and it will not go beyond this area. Automated dispensing or dosing systems are the best example, which does not involve any handling and transportation of chemical. Easy access for transport in chemical store is important. There will not be any collision, or the chemical transportation will be in safe manner. Fire extinguishers and SDS should be located close to store's entrance. So these are some of the good practices. So SOPs on storage of chemicals can include a section on good housekeeping practices. So some of these good housekeeping practices that include: do not use open flame from welding or cutting torches in the areas where flammable chemicals are stored. Do not use any chemical without reading all instructions given on the label of the chemical container. Do not mix chemicals without full knowledge of their compatibility, or that can have some hazard. Do not roll liquid chemical drums on the floor. Use some trolleys to move them around the workplace. Do not have food or leave the stores without washing your hands after handling the chemical. And do not smoke in the chemical storage area where flammable chemicals or other chemicals are stored. So I'm just coming to an end of this webinar. So in this short time span, it will be very difficult to explain this topic in great detail. However, in case you are interested to get additional information, Nimcatech provides online training course for this particular module. So you need to visit www.nimcatech.com. On visiting, you will get this page and you can log on to Notes platform there. So this is our login page for Notes platform. Once you provide your details over here as a new user, then you will be directed to a registration page. So you need to fill the required fields which are given here, and once these fields are filled, then you click on the self-learning course that is required. So we have different modules in this chemical area covering brand RSLs, restricted substances, chemical management for compliance, etc. And then once you register here and pay, then we will allocate you the module, which can be found in My Courses tab. So once you will be allocated the module, you can just click on launch to start the module. So this online module will have certain benefits, like you can access it for as many times in a 5 days period, and this will help to understand the topic completely. There are knowledge checks which have been placed in between the module so as to understand whether the user is able to grasp the module. Apart from this, resource materials or additional informations are related to this topic are also given to user in the form of soft files. So here we come to end of this today's webinar. I thank you all for attending this webinar. In case you have any questions on this webinar, please send your questions on adminnotes@nimcatech.com and we will try to answer your queries. Please also stay tuned with the Notes Club newsletters for upcoming webinars. With this note, I look forward to see you in Nimcatech's upcoming webinars. Thank you once again and have a nice day. So I would just like to ask, are there any questions regarding this webinar? So you can ask and you can type in the chat box. So one question we have, that is, when do I update my chemical inventory? So well, this is a good question. You should update your chemical inventory periodically, and as and when there are new chemicals which are added in your factory or facility. Once you get these new chemicals in your factory, you should also ask for SDS or MSDS of that chemical and find for the hazards in that chemical through section 2, H statements given in section 2. So there is one more question, that I need to understand brand RSL module course. So you just check out our website. You can go to www.nimcatech.com and the list of modules is provided over there. So you can get this online module. As I just told you that you can purchase these modules online. Only thing is you need to visit our website, you need to click on the new user and provide the detailed information asked there. Then we will allocate you this module on payment for the module. One more question which is somewhat not related, but what is the use of sludge? So any textile waste which is a kind of sludge is a hazardous waste, and hence this sludge needs to be disposed in appropriate manner. So in case the sludge can also be used as fuel for cement plants and to make the bricks. So there's one more question, that is, please repeat the risk assessment calculation. So I will just go through the slide. So firstly, you need to have inventory of your chemicals. So as mentioned here, you can see that you should have the name of chemical, supplier name, use or application of that chemical, place of use, then availability of SDS or not, and then with the help of SDS section 2 you can find the H statements mentioned therein and get a description of hazards. Once you could identify the hazards in chemicals, then you also check that with the help of TWA, that is time weighted average, and threshold limit values, the amount of exposure, or you need to map the exposure of this chemical to the worker who is working there. And after mapping the exposure, the next step is to develop a control measure summary sheet, which should include chemical name, in which process it is used, what kind of personal protective equipments are required for use of that chemical. This data will be obtained from section 8 of SDS. Then whether this chemical is flammable or not, that you can get from the pictograms or H statements. As I said, H200 series denotes physical hazards. So if any H statement which starts from H200 and something, that denotes physical hazards. And then you should have a phase out list of chemicals pertaining to acute health hazard chemicals, like some chemicals may cause lung damage or some chemicals are carcinogenic. So on the basis of H statements, you should check for this phase out list of chemicals and write the reasons for phase out. So this is how you should develop a control measures and phase out list of chemicals. If a chemical has no CAS number, then what should we do? So if there is no CAS number which is detailed in the SDS of the chemical, then I think you should contact this chemical supplier and ask them to provide MSDS or SDS with exact 16 sections, and you can see that section 3 of this SDS or MSDS that provides you information on the CAS number. Or even there is other way, if say example it is a basic chemical or most of the chemicals CAS number information is provided on public databases. You can just type in Gestis, Gestis, in Google, and then you will find that a database is available for chemicals. So you can type in the name of chemical and you will get the information on CAS numbers pertaining to that chemical. So there is one question that somebody was asking for a presentation of this. However, this presentation is not available, but a recorded webinar will be available, which we can mail it to you. So in case you have any other question or questions or queries, then you can please mail it to adminnotes@nimcatech.com, or you can mail it to me, vivek.vani@nimcatech.com. We will try to answer your queries. Thank you very much.